Today we're going to dive a little bit deeper talking about proportional graphs. So here's an example from our previous lesson. So a proportional graph is a straight line and it starts at the origin, which is 0, 0. That can also be seen in the table. Oh my gosh, what are the chances of the lights going off? 2 videos in a row. All right, so last year you had learned about slope-intercept form, which is y equals mx plus b. Since b is 0, the equation is y equals mx. M stands for the slope. However, there are other names for the slope, such as unit rate or the constant of proportionality, which for that we would use the letter K. It comes from the German word of constant, which starts with a K. So the equation might also be seen as y equals kx. All right, if we are only given a table and it chops off the beginning part so we can't see the zeros, the easiest way to figure out what that slope or unit rate is to take the ratio of your y variable, or the y coordinate and your x coordinate. So if you were to graph 1, 3, 1 is your x value or how much you go over, and then 3 is the y value or how much you go up. And it's y first over x. So it's 3 over 1, and that can then just simplify to just 3. Or I could do 6 over 2, and that also would simplify to 3. So that equation is y equals 3x. Right, so for this next one, let's say I take these two. It would be 6/4, and that can simplify to 3/2. So it is probably easier to start with the first ones, but you might not always have the smallest numbers. Sometimes you do have to simplify. Make that larger so it's not as awkward. All right, sometimes you have to write an equation given a graph. All right, so to find the slope, you can go up and over. Rise over run. Finding slope is so much fun. So for this one, we have to go up 1, 2, 3, 4 over 1. And 4 over 1 is the same as just 4. All right, so for this one, we can go up 1, 2, 3 over 1, 2, 3, 4. 3/4, and we cannot simplify 3/4. All right, sometimes there's not always going to be points. So if I look here, this line, I'm actually going to change the color a second. Let's make it this one. All right, so this line does not pass through an intersection right here, nor here, nor here. It's kind of just passing through random streets. But right here, it does pass through this intersection of those black lines. So there would be a point here. There would also be a point here because that pink line is passing through this intersection. Okay? So if there's a point here, to go from the origin to that point, we'd be going up 3 over 2. So that would be the slope there. And for this one, there would be a point here, and here, and here. So wherever that line crosses one of these intersection points. All right, so for this one, we'd be going up 1 over 2.